5 times 5 is?
25.
Yeah. Folks, welcome out there this great afternoon. Thank you for tuning in today. I know it's a busy time for a lot of folks. We are getting ready for a great evening, Valentine's Day. I'm Ernie Roberts. I am your host for Mathline this evening. And I hope, we always say like us on Facebook. Today, go and love us on Facebook, all right? Show us some love up there. Give us shares and a few other things and all those good things. And you know what? We'll have a good time today on the show. Now, what do we do on this show, by the way, since I've already told you about it being Valentine's Day, which you knew already, right? Everybody's taking care of those details. 844-686-2378, that number you see going through. We love that number because that's how you connect to us, talk to us, and we will work problems live together here on the air. That's what we're about, okay? A little service to you. It doesn't cost a cent, and hopefully have a lot of fun while we do it, okay? We know a lot of our viewers are out there ready to rock and roll. I am too. Let's go with the problem of the day. Hey, look at all that. Thank you, Connor, for all those great hearts and good things there. My director working hard for us here. Even the Mathline looks like Valentine's Day here. Wow. Happy Valentine's Day. Let's solve this equation for the variable x. All right, we always have the x. I guess we could have put the variable heart up there or something. But anyway, we didn't. We've got x running through there. And it says 2x minus 14 equals 20x minus 19. I kind of like that equation. Y'all take a look at that and see if you figure out why I really like this equation. I got answers of it on Facebook. I'm not sure if anybody really caught the whole gist of, let's try to plan this one out a little bit. But we'll take a look at it and let's work it through and let's see what's going on with it. How about it? It's even got a little bit of redness for you up here, all right? So happy Valentine's Day to everybody once again. We're going to solve this equation for the variable x. And we've got 2x minus 14 equals 20x minus 19x. So at home, take a chance. Go ahead. It's not a hard equation. We try to make it easy for the holiday, all right? So we make a little bit good for our Valentine's Day. But let's see how this works out. First of all, I've got a lot of x's running around here, and I would like to fix that just a tad. So let's go over here. Those can be combined because, yes, they are on the same side of the equals. So let's take a look at that. Oh gosh, that was easy. 20 minus 19, not much to think about there, is it? So we'll put an x right there because that's really 1x. If you want to put a 1 there, that's fine. Go ahead. But x is what we have. On the other side, we haven't done anything yet. How about that? 2x minus 14. But I do notice one thing going on here. We've still got x's on both sides. We need to move that around. So why don't we do this? Why don't we move this 2x over to the right? And this works for me. So we're going to subtract 2x from both sides. We're going to subtract it here. And we're going to be very careful. We're going to be very careful. Because remember what we do. If we subtract it from the left, we got to subtract it from the right. That is the good old, what? You got it? Yep. Subtraction property of equality there going on. What do we have now? We have the 2x is gone on the left. We have a negative. Please don't forget your negative 14 on there. Okay. Equals. And remember, I said there's a 1 there, so it's like a 1 minus 2. We're going in negative territory over here. It's going to be a negative, or opposite of x, as we like to call it. That's a problem, okay? Or a negative 1x, if you want to put it that way. It basically means the same thing. What we want to watch out for here is the fact that we need to change sign. We aren't trying to solve for the opposite of x, or a negative x, or a negative 1x, however you want to look at that. We're trying to say what is x equal to. And you know what? If we divide by a negative 1 to both sides, we're going to end up with x equaling 14. Now that's what a lot of the Facebook folks turned in today. We had a few that did respond to it, and that's great. We love it when you get into the equation mood with us and such. We're going to see if they're right, okay? So what we want to do, we want to put that thing, substitute that little puppy back in. Here we go. 2x minus 14 equals 20x minus 19. Probably should have had a contest on the air or something today to see if anyone can see the significance of this equation. Think about what today is. Happy Valentine's Day. Look at that equation. Does that tell you anything? Hint. We'll come back once we check it. After we check it, I'm going to come back and I'll spill the beans to you if you're still trying to figure out what's he talking about. We put a 14 back in place here. So we're going to have 2 times. It looks like 14 minus a 14 equals, woohoo, 20 times 14 minus 19 times 14. Now, I'm going to tell you something here. That part's easy. 2 times 14 gives us 28. We're going to subtract the 14. Think about that a minute. You don't need to think about it, right? You already can tell the answer, can't you? But on this side, what I would like to do is let's play a GCF moment here on this thing. You say, what do you mean GCF? I see a 14 in both cases here. So let's pull 14 to the outside. And let's see what happens when we write 20 minus 19 back in there. Let those people wonder, well, why do we do certain things? Well, we can make this problem a lot easier, because what's 20 minus 19 back there in the parentheses? Oh my goodness. Yes, everybody's thinking with me, right? Exactly. It's going to be 14 times 1. Well, this thing over here is giving us 14, and I'll be honest with you, folks. Yes, 14 equals 14. Our problem of the day is solved there. Now, let's go back and look at what we have here. I still want to have a little fun with you this afternoon. You know, yeah, we like to have fun on Mathline. 2, 14, 2019. Oh my goodness. Could that be today's date? I believe it is. Valentine's Day, February 14, 2019. Maybe you could have put a plus there, but you know what? You wouldn't had nearly as pretty answer on that. So we'll tie it. By the way, X came out to be 14, which is even great because that's the day today. And by the way, folks, be sure you've taken care of the loved ones and parents, children, wife, girlfriend, boyfriend, husband, all those good things, everything. Be sure you've taken care of them, because you could be in the doghouse this evening if you haven't gotten those flowers, those cards, candies, all those good things that make Valentine's Day rock for us here. But thank you for tuning in. Thank you for spending your Valentine's Day afternoon with us. Now we're going to ask you if you'll give us some love and call us, all right? 844-686-2378. Now, we can entertain you. We can certainly do that and make life easy for you here. But we'd like to hear from you. Okay? And there's some problems being worked out there in the world of schools, and also with our adults, probably some interesting things that are happening. So give that number, 844-686-2378. Give us those calls, and let's see what's going on. I tell you what, I know it's been going on all week long here. We've had this thing called Problem of the Week, and we want to figure out where did things end up on this. So, Connor, let's take a look at this one real quick, all right, and finish this one off, and we will see. We get some calls, all right? While we're doing this, go ahead and give us some calls, dear friends. Now, remember we left off yesterday. We said we have a cylinder and a pan. We have the cylinder, the cylindrical glass, or a cylinder we'll call it, filled with water. Now, it had dimensions of 15 centimeters, 4 centimeters for a radius. So remember, it's like a tin can type look, but it's a rounded glass. Goes straight up. We're not going to have any, pretty shapes or anything. It's going to be pretty straightforward. It's full of water. And we're going to pour all that water into a rectangular pan that is 5 centimeters, 15 centimeters, and 10 centimeters for dimensions. Now, we left yesterday with your dimensions. We left you with a formula. And we basically did about anything but just work it out. So today, that's what we're going to do. I'm going to pull back over here, and we're going to go back to pi r squared h, which, remember, that's a circle. It's a base circle times the height. And over this side, by the way, it's volume we're talking about here, in case y'all have not been with us for a while. We're looking at volume. And on the other side, the volume is really easy. It's just the three dimensions multiplied together. And we are going to come out, in this case, it looks like with cubic centimeters, which become some sort of milliliters, et cetera, et cetera. So we're not going to get nervous about that. We're all about cubic centimeters. So we're going to see how they match up here. So putting it in there, I have pi, which I'm not going to worry about yet. I do have a radius of 4. Now, if I said a diameter of 8, you make the radius 4. So we're going to put the 4 in there. We're going to square it. And how tall is this thing? Oh, it's 15. Now, I hope some of you noticed, and I'm sure you did, because you guys are astute that watch this show. You really are astute students and pupils. And I'll say astute is a very complimentary term, by the way. Look that one up if you need to. We have volume equaling, how about it, 5? That was our length, times 15. See, we have a 15, but that's what I meant. A lot of you will notice that right off the bat. So the 15 could basically, for all practical purposes, be taken away. But let's find the volume for real, all right? And we have a 10 left over. Oh, everybody in? Everybody in for the ride now? Let's go for it. Let's see what we have. 4 squared, of course, is 16. And I want to be real careful here. I think that's 240. Let's check though. 16 times 15. It better be 240. Yeah, there we go. So we got pi times 240. So while we're at it, let's go ahead and multiply by pi on the calculator. Y'all know how to do that? We'll put a time sign just to make sure we don't mess up. And hit second, and then we find the pi key, which is right underneath that exponent raising moment. You see where it is? We have to go second and hit, it was blue, now it's turned red. So we've got to go with the pi right there, and we have pushed it in there, and you see what happens. It's pi. Press enter, and we got some crazy looking number. The volume is about, looks like, why don't we just say 754, what is this, centimeters cubed. That's going to be closest. That's rounded off because it was like, 98 hundredths with a little chump change after that. So we'll keep it at 754. Now the big question is, what are we going to have right here? This looks like it's going to be a close race, my friends. That's 75 times 10. Oh my goodness, it is a close call here. The volume with this one is 750. And by the way, those are cubic centimeters also. So is it going to overflow? Just barely, but it is going to overflow. So the question is, will the pan overflow? Some of you got yes, some of you got no. Uh-oh, no was wrong, but it's real close. It's very close. But again, it's all about the formulas, and hopefully you had a little bit of fun with that one too. It's an interesting little connotation, and some of you may have made the prediction even without it, but it's really, really very close. Those numbers are very close. So you said it's going to be a trick question or going to be the same. I couldn't quite get that because that pi kind of messed things up because it's so irrational, and the decimals were going to mess up somewhere in there, so we wouldn't get an even number, we know from that. But the question turned out pretty close. But it looks like, yep, the cylinder had just a little bit more water, about 4 cubic centimeters more, which isn't an awful lot when you think of those big numbers. But speaking of big numbers, we've got one, right? 844-686-2378. Give us a call. Like I said, give us a little bit of love this afternoon. We would love to hear from you guys. And I know we have heard a few things, and I understand, I think we got a Hey Mathline waiting for us. So let's see what we got with Hey Mathline.
Hey Mathline, I am Sawyer Shepherd from Powell High School in Powell, Tennessee. How many ways can a person take 10 cards and make a hand of 5 cards with no repeat combination?
Sawyer, good to see you once again, and we've got a great little thing going here. It says, how many ways can a person take 10 cards and make a hand of 5 cards without any repeat combination? This is one of those combinations questions. So some of you may be playing cards tonight. No, I doubt it. It's going to be one of those nights for Valentine's Day. It's usually not a card playing night, right, ladies and gentlemen? So, but let's go ahead and take a look at this one anyway. We're going to have a little format here. It's called 10C5. C stands for combinations. We have 10 items taken 5 at a time. That's our notation here. We got the calculator, and that's the way most students, most of us like to do, but I like to also show you what's going on here, all right? So here's the option, and here's the story. First of all, we're just going to go back to a formula. I'm going to say big C, and let's suppose we have N items, N events, whatever, and we're going to take 5 of those at a time. We want to see all the possible ways we could reach in and pull out 5 different cards. 5 different cards over and over. How many different ways? And still not come up with an exactly repeated hand. And when I say an exactly repeated hand, remember, it's a combination because it doesn't matter which order they come in. So that's a hint. That's why we're going with combination on that. And plus the word combination popped up in the problem, right? Pretty straightforward. Now, you say, Ernie, is there a formula? Of course there's a formula, isn't there? We're going to put our n factorial. And you say, what does that mean? Well, in this case, we'll put a number in and we'll find out, all right? By the way, I'm going to call this x. Not so much that. I want to use a formula first. We'll put a 5 in there. I just got a little crazy, a little carried away. But we're going to say n items taken x at a time. Or in this case, it's going to be 5 at a time. We're going to be putting in there. The formula says we start with n factorial, and then we go to this little guy here and take it to a factorial. Now, what do you say factorial means, Ernie? Well, if, for example, since we know x is 5, I've already given that away pretty hard, haven't I? And that's going to be 5 times 4 times 3 times 2 times 1. This other side, however, now let me point out, if you left it there, you would get a permutation. you would be able to get all those 5 cards, and the order would matter, which one you got first, second, third, fourth, or fifth. Now, since you're just playing a hand of cards, you arrange them right after you get them dealt to you, so order was not important. But let's say, suppose you had a high card to begin with, and that was going to determine if you played first or not. It becomes important, all right? So then we start worrying about how things come into your hand, all right? How they're dealt to you with order becoming important. But most card games, you get to look at all 5 of them, play the game. So what happens then is we have to adjust a little bit more here, and we're going to take this in, and we're going to subtract x. Then we're going to run a factorial. And notice all of this is division, which tells me, before I put that down there, I can put my fingers over it. Ooh, they don't look very good, do they? I'll use the pen. That looks a little bit better here. I don't want to, there we go. And when you lose that, that's a lot more than this, because we're going to divide something else into that big number at the top. So let's play it out. Let's put the 10, since we've already given it all away. Here you go, Sawyer. You've been waiting for this, right? We'll put in, and we'll put a 10 factorial right there. And we're going to put a 5 factorial right there, and how about a 10 minus 5 factorial right there? Because some of you are going like, where'd you get the second 5? Well, we're going to subtract 10 minus 5, so just hang on. Now, keep it going here. We'll straighten up a little bit. We got that 10 factorial going on. We got 5 factorial times 5 factorial. Let's work this thing out. All right, let's get this thing going. Again, this means 10 times 9 times 8 times 7 times 6. Woo, keeps going on and on. But you know what? At a certain point, when we get to 5, we've still got 4, 3, 2, 1. I'm going to put that in there and stop it right there. Why did I just do that? Because I'm going to be able to get a cancellation. Now, I've still got another 5 factorial hanging on, but at least these are gone. And all of a sudden, my numbers are looking a lot better. Now, let's take another little point here. Let's go to this point here. What is 5 times 4 times 3 times 2 times 1? Well, we can figure that one out, I think. We're going to take 5, which is 5, of course, times 4 gives us 20, times 3, what do we get, 60? Then times 2, we're up to 120. So we've still got this crazy number on top, which I guess we can run a calculator moment on it. Let me do that with us here. We've got 10, that one's easy, times 9, times 8, times 7, times 6, whew. And that was what we had left, right? So it looks like we have 3,000, oh goodness, how about that? 3,240, and we're going to divide that by 120. You want to go ahead and do it? Yeah, let's do it on the calculator. I don't want to do it by hand. Let's see, we got 120 divided into that. We're at 252, and that's really what we were looking for. So our calculation here, Sawyer, is for 252 combinations for that hand of cards. Now, that was a long time, didn't it? That took, what, about 5 minutes of our time here today, maybe even a little bit more. Let's take a quick look on the calculator how you can get this done real quick. You're going, yeah, we're looking for quick. So clear out everything and type 10. And this is where we have all these lovely keys over here that a lot of people go like, what are they good for? Well, let's go to the math key. It's good for something. It's got a lot of things. We can tell you can change fraction, change a decimal. You can cube something like this. You can find the cube root. You can find any root you want. And then you get kind of crazy here with mins and max and derivatives and in things. So let's not go there, but let's go out to probability. All right, that's where we're interested in right now. I just had to give you all the, look at all those things this thing does. Just by cursoring off, you got all sorts of functions you can do. And we've got some interesting things. And see that little notation at number 3? That looks like what we've been doing. NCR. And look what they gave you a C, and it says fill me in. Well, we know what's going in there. We're putting in a 5. Some of you saying we're putting an X. No, we're putting a 5, folks. Let's play this one out and see what it gives us. Hopefully it gives us 252. How about that? There it is. So your calculator, graphing calculators, and computers, all sorts of things, have been programmed to handle such things as factorials and all those other good things that work through. So you probably noticed the factorial key back there. You could have gone back and put 10 factorial and then 5 factorial, and worked them out and probably gotten the same value if you put parentheses and did it the right way. Sometimes things get a little confusing there. Be careful in that regard. But there's your answer, Sawyer. Hope that works for you, all right? And appreciate you calling in and giving us that little video moment with us, all right? And those are some good things there. That's some good stuff there. Now, while we're at it, speaking of good stuff, let's take a geometry moment here. We had a little statistics there. We already had some geometry. It was good. Did a little algebra. Let's take a little bit more of some geometry, but you know what else we're going to get out of this? We're going to do some algebra. We're going to fuse it together. How about that? Valentine's Day, we fused the algebra and geometry together, and we put a little bit of red print out there, a little love at you, okay? So it says area of a parallelogram is 32 square feet. The base is 4 feet more than its height. Oh, goodness. Word problems. Making you think on a Thursday afternoon, aren't we? By the way, speaking of thinking, give us a call, 844-686-2378. We really, really love to hear from you on this afternoon. It would be great to hear from you to finish out our show. But what do we got going on here? We have base height. That's what the area is. It's all about the area. How did I know it's about the area? Because they told me so. And I've got a number. I got 32. So that helps. But let's write a formula first. Base times the height. That's our formula for area. And that's pretty straightforward, isn't it? There's not much to worry about there. Not a lot of hard stuff going on. But we're going to keep working it through. We're going to get it through. Now, what we have is, we don't know the base. We don't know the height, do we? But we do know the area, so let's put in what we know. Let's do this for the base. It says it's 4 more than its height. So we'll just let h be the height. And the base, we're going to let the base equal to 4 more than that. Okay? Isn't that what it says? Base is 4 feet more than. That means put a big plus. Then its height. There's nothing else about the height. We don't need to make it mysterious. It's just an h. All right? So what are we going to do? We're going to multiply. We're going to put in h plus 4 in place of b. And we're going to put an h right there. Well, that wasn't so bad, was it? Not very painful at all. And you know, a lot of times we like to see the h in front of the parentheses. It's okay. We're still going to distribute the h through h plus 4. So we've got, it looks like 32 equaling, h squared plus 4h. Magic. And all of a sudden we're going like, what do we do now, Ernie? What do we do now? Well, what do we do now? We are going to set this thing equal to 0 and factor. And you know what they're going to do? They're going to probably drop the bottom third out of me on here. So let's finish this thing off. The deal is subtract the 32 because until we have 0 here, it's very hard for us to isolate and factor things. That's what we have to do when we factor and solve is get a 0 involved. So we're going to subtract 32, and I'm going to put that minus 32 way out there. So nobody, absolutely no one is tempted to subtract it from h squared or from 4h. It stays separate. It's still subtracted, but it's not going to make like 28h with a negative or some craziness with the h squared. It's going to be simply h squared plus 4h minus your 32 equaling 0. Now, the game plan, that's a 4, by the way. Yes, everybody's good on that, right? We're going to put in factoring time here. So we're going to do just that. We're going to break this thing open into 2 parentheses. I'll go ahead and put the equals 0 to the right. Just makes me feel a little better. And looks like we've got this h squared. Let me put it right underneath here. We got h squared plus 4h minus 32. That minus 32 is important, equaling 0. So the 0 just came straight down. We're breaking up this trinomial. And we had h and h. By the way, Ashley asked us about something like this earlier. Okay, this is very similar. She asked earlier in the week. We've got a trinomial. We're ready to factor it. Okay, plus and minus. Why do I put plus and minus? Because I got to get a negative 32 on the end. Multiplying by positive times negative gets me where I'm going. Again, I look in the middle. I got to make sure things check out. It's like a little puzzle. There are lots of ways I can multiply, get 32, but only one way I can come up with a plus 4 when I add the factors of 32 together. And I'm thinking 8 and 4 sound good because that's the times table. But also the separate difference is 4. Where are we going to put the 8? We're going to put it on the plus, 4 on the minus, because look, quick check. 8 minus 4h gives us 4h back in the middle. Now, are we done? Almost. How about it? We got h could equal negative 8. Well, that doesn't make any sense. This is a parallelogram. It's a base. It's a height. Can't be negative. Over here, what minus 4 gives you 0? Well, that option is 4. I like that one. It's positive. Don't like this one. It's negative. And we've got a 4 that's going to go back in here. Let's see. Do we get 32? So if you put a 4 right here, you put a 4 plus 4 right there, oh my goodness, you got 4 times 8, which we know is 32. Check it out. It checks. Everything is good. The problem makes sense. I hope it did anyway to you. And we got it solved. Now, speaking of solving, we are here on Valentine's Day. Tomorrow is a great specialized segment. We got some good stuff going with, my goodness, triangular prisms, right? Triangular prisms, which basically have to do with surface area. Now you say, well, what about volume? We don't have volume tomorrow. We do have surface area, and it's a lot of fun. So you want to check in on that? And on Monday, we're going to be talking about President's Day. We're going to talk about the president's ages. We're going to see how do they work together. Can you believe that? And you will have to check it out and see. But that's Friday and Monday. We'll be back live on Tuesday. Thank you for tuning in today. Happy Valentine's Day, and we will see you again next time.